So welcome back guys, this is Madhav PVL and today we are going to discuss about stack. So let me just open my paint. I'm going to explain today's video along with this implementation of a stack. So basically, stack. What is meant by stack? So stack is nothing but it's a linear data structure. So stack is just a linear data structure in which it follows a very basic principle like LIFO. LIFO is last in, first out. We can write this in a reverse order. So first in, last out. So basically, what is meant by this last in, first out? So to know that, let me just give you some real life example. Like now, let us just consider a CD bar. CD bar is nothing but in our before days we used to just store the CDs in this with the help of a plastic disc like this. So yeah, consider this. So now I'm just inserting one CD, and this is second one, and this is third, and this is fourth, and this is fifth, and this is sixth, and this is seven. So now I had inserted seven CDs in this disc bar. So if we need to just get this second CD, then what is the procedure? We need to first remove this and then next this, and then we need to remove this and also this one and this one. And finally, now we are getting this second one. So after removing all these, we will get the second one. So this is nothing but, so what we will insert at last will be the first out. So if we want to just get this seventh CD, then this will not take that much time. So seven CD is on the top. So it will just remove this seven CD first. So the last input will be the first output. So this is the very basic principle which is followed by stack. So the operations which can be done with the help of the stack are push. Push is nothing but insertion. Insertion of elements is push. And then pop. That is deletion. And the next one is top. And the next one, so push, pop, top. I think these are fine. So let us just get into the code. So let me just copy this operations code. I think this is enough. Yeah, till here it's fine, I think. Yeah. Now let me just copy this in a notepad. Uh, Let us just trace this from here. So this is public class stack operations, which is a generic, and it is just declaring a size of a, and then int size, which is public stack operations, which is a function with a written type and size. So this dot size is equal to size. Top of the stack is -1, which is initialized by us, and a is equal to t, that is generic and its size. So now we are declaring this like this. So boolean is full. So I just forgotten is full and is empty. Yeah, now these are also the two functions which we need to discuss now. And now let us just get into the code. So boolean is full is nothing but, so let us just consider one stack. So if we just consider the stack, so this stack size is 5. So we can just insert the elements up to 5 maybe. So now if we just insert 1, 2, 3, 4, and then 5. So after inserting this 5, if we need to just insert one another element, that is 6, so there will not be any position. So that is full. Is full is nothing but the elements are filled till the top of the stack. That is the elements are till 5. So this is 0th in the index. So we will represent the indexes from 0 to n minus 1 positions. So the elements are reached till top of this stack, then that is full. If they are not till top of the stack, if it is following this condition, that is it is still in -1. That is even it didn't touch till zeroth index, then that is empty. So these are the two conditions which are empty and full. So Boolean full is nothing but if size -1 double equal to top of the stack. So size -1 is nothing but, as I had said before, uh, we will just perform this until the top of the stack. So this is nothing but 5. So the index of this is 4, that is size -1. So if size -1, top of the stack is double equal to size -1. So top of the stack is 4 and then size -1 is 4. If 4 is double equal to 4, then this condition will satisfy. So Boolean is nothing but it will just return true or false. So if E is full is true, then we can't insert more elements. If is full is false, we can just get to this, we can just insert some other elements. So public boolean is empty. So is empty is nothing but if top of the stack is -1, as I had said before. If it didn't even reach till zeroth position, then it is -1, as we will just initialize the top of the stack as -1. So the -1 is like this. So now push. So push is generic of X, so throw stack exception. If is full, then we can't just insert any other elements, as I discussed it before. Now if we just insert 5 elements, that is 1, 2, 3, 4, and the fifth is there. So if we insert 5 elements, then is full condition is satisfied. So it will just throw a stack exception like overflow. Then otherwise a plus plus of top of the stack is equal to plus. So the top of the stack will just first increment, then x value will just come here. So from -1 it will just increment to 0, and then in 0 the x will be stored here. So this will become x. So it will store like this, and then public t pop. So pop is nothing but the top of this stack will be removed in this pop. So is empty. So so for insertion of an element, we need to just check this is full, and for deletion of an element, we need to just check this is empty. So while checking is empty, if it is empty, then it will just pass a statement like underflow. Underflow is nothing but no elements are there to just pop. So otherwise it will just return the value like a of top of the stack minus minus. So first it will just return the top of the stack value, and then it will just decrement that thing. So that is pop. And then top is nothing but if E is empty, then it is underflow. Else it will just return the value which is at the top of this stack. So this is up to this stack operation. So this is for exception handling. So exception handling is done in stack with the help of this thing, and this is the main. So main, I will just explain it here. So public static void main. So here we are just declaring a scanner element, and we are just passing a command like enter the size of the stack. So this is in stack. So scan dot next int, and then this is a generic boolean b is equal to true int ch while b. So while b is nothing but for the recursion of a menu until we will just terminate the program, and then ch is for entering the choice. So ch is equal to scan dot next int. So case 1 is push, and then case 2 is pop, and then case 3 is top, and then case 4 is display, and then finally break. So basically we need to just check how to write this. So it will just enter the element to push, and then x is equal to scan dot next int and s dot push of x. So it will just return back to push. So after returning back to push, here we can just see this push t of x. So the x value is nothing but the element which is to be pushed. So it will just store in the form of t of x. T is nothing but the generic, and x is the element which is to be pushed, and then break. And the second case is pop. So pop doesn't require any element to just pop. It will just pop this top of the stack. It will just return here and perform this condition. and then do it as required. And then case 3 is top. So top also doesn't require any element. It will just returns the top of the stack element. And then after that, that is a display of the elements, that is print stack s comma size. So this plays a crucial role. So print stack is another thing which we need to write. So let me just explain this. So print stack is nothing but while is empty double equal to false, temp dot pushes s of top. So s of top will be sent to this temp dot push. So the elements will be pushed into the temp and then s dot pop. So now here two stacks are going to create. So as similar to this, one another stack is going to create, and this stack is S. So this stack is S, and then this is temp. So the temporary stack is created, and then this stack is S. So one of the element will just pass into this, one of the element will just pass into this, and then here the element will be popped. So it will just follow this LIFO condition, and also it will just transfer the elements into temp. And then finally, while temp is empty double equal to false, so t is equal to temp dot top, print t temp dot pop. So it is just going to print the elements and the top of the temp to the outside, and then just it will just bring back its elements to its s. So after printing this elements to outside, it will just bring back to this s. So it will just follow this basic condition, and it will just do the sprint stack, satisfy the sprint stack condition. And finally, it will just print all the elements to the outside by using this print stack. And finally, while b is equal to false is nothing but this is just for exiting from this while condition. So if b is equal to false, then it will just come outside this while loop. Then finally, the code gets completed. So this is the stack along with the implementation. Thank you for watching.